Welcome back. Today we're going to be looking at threading in Python. So what is threading? Well, it's not threading a needle, but we do need to understand what is a thread. And actually in a processor, a thread has a different meaning to what it is in Python. So a thread is a separate flow of execution, and you can have different threads happening at the same time. So for example, one can be moving the mouse. Obviously this might not be something you do in Python. Another can be pressing the keyboard. You can do them both at the same time, and even though they happen at the same time, they don't really, and that's because you have this diagram. So you can see that the first thread is executed a bit, and then the second thread is executed, and then the first thread goes back to get more processing time, and you can see that happens as time progresses. But this happens so quickly that it appears that both things are happening at the same time, and you might think, is this faster or is it slower? Because if it's faster, we should do it. And it is faster if there's lots of waiting. So for example, you're getting web requests. That takes a lot of time for the request to be sent and then respond. And if you're doing one after the other, that might be quite slow. But if there's lots of heavy computation, it will definitely be slower, because you have to carry out one thread and then save the result and then start executing another thread and then save the result. And a bit like the way human multitasking is a lot less effective, the process of doing it is a similar thing. And the way we do this in Python is using the threading module. So the first thing we're going to do is say from threading import thread, because this is the main thing for threading, is using threads. We're also going to import random and time. And so what we're going to do is we're going to create a thread, and so thread is a thread, and it needs a target, and you can see that the target is callable, so that means basically it's a function, and we're going to put some args in as well, and this is an iterable, so we'll probably use a tuple. So first let's actually define a function we're going to use, so we'll call it a function, and it's going to take in a number so we can uniquely identify which thread is which, and we'll print thread and then the number is starting, and then we'll sleep for a random amount of time, and we'll use random.random just so that it's not too long, it's not too short, and then we'll print that the thread is finishing. And so now our target is function, and the args we're going to have is just going to be a 1. This is our first thread, and we're going to put a comma in just so that this is a tuple, because otherwise it just works out 1, and it wouldn't be a tuple. So before we print this, we'll print creating thread, and then we'll print here starting thread, and then we'll start the thread. And if you don't do thread.start, your thread doesn't do anything. Something, again, that you want to try not to forget. And then we'll print all done. And so we'll say Python and run it. So something weird has happened. So we've created the thread, we've started the thread, and then we've finished, and then the thread is finished. And that's because there's this wait time in here. So this main process is running, and then it's just waiting for the thread to finish off. So if we instead, what we can do is we can print here waiting for thread to join, and then we can do thread.join, and now it will wait for the thread to finish, and you can see it's waiting for the thread to join, and then the thread finishes, and then it's all done. Another thing that's interesting is daemon threads. So we set daemon to true, and we take out this line. You can see that it starts the thread, and then it says all done, and the thread doesn't even finish, because it's still running, but it's in the background. So the actual code is finished running, but the thread is still going on. And this might be useful for some background tasks that you have maybe every hour. But again, if we put this line back in, we can see that it waits for the thread to finish. But we're going to leave that out. But what if we have multiple threads? So what we'll do is we'll say for I in range 10, we'll create a thread, so we'll say thread is thread, and again we'll say the targets function. And this time we'll say the args are I, so that we can track each thread individually, and we'll say thread.start. And we're not going to use this bit, and we'll just see what happens. And you can see, you know, the threads have started, they've waited a bit of time, and then they finished. And they finish in a random order because of the random wait. One of the things that I think is interesting is if we take this out and replace it with, for example, 1 second, run it again, they still finish in a random order. So we've started each thread, and then we're just waiting for them to finish, and that's quite strange. And the reason this is happening is because the order in which threads are processed is handled by the processor. So the processor decides which threads get how much time, and so if we ran this again, they'd be in a different order, and this depends on so many factors such as what else is running. And there's not really much we can do to make sure that each thread finishes in the same order it started. What we could do is say that we have a list of threads, and each time we're going to append the thread to the list, and then we can say for thread in threads, thread.join. So we wait for each one, but you'll see even when we do this, this hasn't made that much difference. That just means that if we then had, you know, this all done at the end, then it would run. So you might think, you know, let's say we wanted something where the threads are all working on a problem, like they're all getting a web page, for example, but they need to get 100 web pages, and so we're doing it with threads. So you're probably wondering, how might you do that? And so what we can do here is we can have a global variable, I'll call this count, and we'll set that equal to 0. And we'll now create a different function, advanced function, and this isn't going to take in any args. And we're going to print a similar message to before, thread count is starting, and then we'll set it it's finishing, again with and so here we actually need 2 counts, so we'll have a start count and a finish count. And so what we can do here is we can say this is the start count and this is the finish count, and then we want to increment the finish count here and increment the start count here. One thing we need to do this is to use start count and finish count as global variables, so otherwise we'll get errors. And so now we'll change this line here so that the target is no longer function but advanced function, and it doesn't actually need any arguments because it doesn't take any in. And you can see that put this line in the wrong place because it's saying that all the threads are finishing. And so this is a bit better. I mean, it's not been perfect. You can see that here thread 8 has happened twice and thread 1 has happened twice because it's run this line and then this line. So it's not perfect, but then we can improve on that using locking. And so now we also need to import lock. And at the start we'll say a lock is equal to a lock, and we want the lock to be global, and here we'll lock.acquire. So we're basically saying, you know, no one else can take this lock, and then here we'll release it. So that means that this bit is executed before any other thread, and then we can do the same here. And so now we've got a series of locks. And you see this time the threads start and finish in the same order, although we are using a count still. So this means that we don't have to worry about threads overlapping, and that's worked very well. So you can see that we could race threads using this original function. I mean, putting the random in makes a small difference as well. Or we can use a lock to make sure that our threads aren't racing. So hopefully you can understand threading in Python. You know when to use it and when not to use it. And hopefully you've enjoyed this video. So I'll see you again, same time next week. Till then.